Today, I'm going to talk about the power developed by a force. In the diagram, we have a box being pulled along rough horizontal ground at a speed of 5 meters per second by a horizontal force of 30 newtons. If the friction is also 30 newtons, then there will be no acceleration and we will have a constant speed of 5 meters per second. This means that the work done by my 30 Newton force, moving 5 meters every second, will be 30 times 5, that's 150 joules every second. And the power developed by the 30 Newton force when the box is moving at 5 meters per second will be P is 30 times 5 as above, which is 150 watts. Watts is the units of power. In general, the power developed by a force of F newtons when it's moving an object at a speed of V meters per second is P equals FV watts. Now let's look at a car traveling up a slope at an angle of alpha, where sine alpha is 1/20 to the horizontal. The power developed by the engine is 12,000 watts, and the mass of the car is 600 kilograms. So we have that in the diagram, and we have here the driving force. We're assuming no resistance, normal reaction, and weight of the car. Acceleration A. Find the acceleration when the car is traveling at 10 meters per second. Well, here we have V equals 10. Power is force times speed. And so in this instance, we've got the power is 12,000. The driving force is D, and the speed is 10, which gives us that D is equal to 1200. If we resolve now up the slope, we will get D, which is 1200, minus 600 G sine alpha is mass times acceleration is 600 A. Pressing the buttons, we get that A is equal to 1.51 meters per second squared. Now let's see what happens when the car is traveling at 20 meters per second squared. Very, very similar. V is 20, P is still FV. That gives me my power, which is 12,000. The car's engine is working at that power all the time. That must be equal to the driving force times V, which is 20 in this case, which gives us that D this time is 600. So now if we resolve up the slope, we will get D minus 600G is 600A. Move up to give myself a little bit more space. Resolve up the slope, and we get 600, which is D minus 600G sine alpha, which is 600 times the acceleration. This gives us that the acceleration is 0.51. And so as the car accelerates, it increases the speed. So although the power remains constant, 12,000, the acceleration decreases. Power constant, as the speed increases, the force will decrease, the acceleration will decrease. So now let's find the maximum speed of the car. Maximum speed of the car, the acceleration will be 0. And so if we go back up to the diagram, if the acceleration is 0, the driving force must be equal to 600 g sine alpha. Driving force upwards, 600 g sine alpha downwards. Maximum speed of the car, d, it's not a very good d, is equal to 600 g. The power is still 12,000. And so if v is the maximum speed, then P equals FV. V is the maximum speed. 12,000 will be equal to 600 G times V. Press the buttons on the calculator and V comes out to be 40.81 which is 41 meters per second.